Hello class 10 students, I hope everyone is doing well. So welcome to the last lecture, that is lecture number 5 of this chapter, electricity. So in this lecture, mostly we will practice some numericals and there is one small topic to discuss, that is power. Okay, now see here, in this numerical of type D, we will be using the formulae based on work done in joules and power. Okay, now see here, these are the three formulae for work done. And we know that power equal to work done upon time. So these are the three formulae for power. So guys, you need to know all these 6 formulae. Clear everyone? Now look at the first question. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. So etia question tut ki dia hoy ase swa? Heat dia hoy ase, time to dia hoy ase aru resistance. So we have to find out the potential difference. Okay, now see here, we are given heat equal to 100 joule, resistance equal to 4 ohm and time t equal to. So guys, now can you tell me what is the time here? Yes, it is 1 second. Each second means 1 sec. Okay, so don't get confused. And we have to find out the potential difference. So from here we can use the formula, that is heat H equal to V square into T upon R joule. Now see the solution. So by rearranging the formula, V equal to root over H into R upon T. So formula to V square thoka karne yat root over to ahi gol. Okay. Now by putting the value of H, R and T, that is 100 into 4 upon 1 respectively, we will get V equal to root over 400. Now by removing the root, we will get V equal to 20 volt. Clear everyone? So the potential difference across the resistor is 20 volt. So it is a simple formula based question. Not so tough. Okay, now see here question number 2. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. So it is question 2. Charge to dia hoise, time to dia hoise 1 hour aru potential difference. And we have to find out the heat generated. Alright, now see here. We are given potential difference is 50 volt. Time it is given in 1 hour. So jihetu time to 1 hour dia hoy ase, so ami hour to second ole nibo laibo. Okay, aru second ole convert koribole hole we have to multiply it with 60 into 60. So time equal to 1 into 60 into 60 second. Okay, and charge it is given 96,000 coulomb. And we have to find out the heat. Okay, this was heator tinta formula ase. So from here, which one we will use? Yes, we will use the third one, that is H equal to V into I into T joule. So it is a formula tot current to ase, right? But amar yat current to dia hua nai. So first tote ami current to liabo laibo. So current to liar formula to hoise I equal to charge upon time. So these are the formula we will be using. Now we have to first find out the value of I. That is, we have to find out the current. Okay, so by calculating it we will get I equal to 80 upon 3 ampere. Okay, now leave it like this. Now we will use H equal to V into I into T. So it is V, it is 50 volt. Current we found that it is 80 upon 3 ampere and the time it is 60 into 60 second. Okay, now do the calculation. So we will get heat equal to 4.8 into 10 to the power 6 joule. So heat generated is 4.8 into 10 to the power 6 joule. Clear everyone? Not so tough, but there is some calculation you have to do. Okay, now move to question number 3. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the potential difference and heat developed in 30 seconds. So guys, tumalike video to pause kora for 1 or 2 minutes aru nije try kora, okay, solve koribole. Okay, now see here, we are given current dia hoise kiman 5 ampere, time it is given 30 second and resistance dia hoise 20 ohm. So what we have to find out? We have to find out the potential difference and the heat. Okay, so etia ami kun duta formula use korim? First we will use V equal to IR, that is the Ohm's law, and we will use the heat formula. So এতিয়া হিটৰ তিনটা ফৰ্মুলা আছে। সো ইয়াত আমি কোনটো ইউজ কৰিম? Yes, again the third one, that is H equal to V into I into T joule. Okay, now see the solution here. First we will find the potential difference. So আমি জানো যে কারেন্টটো দিয়া হৈছে 5 এম্পিয়াৰ আৰু টাইম দিয়া হৈছে আৰু ৰেজিস্ট্যান্স দিয়া হৈছে 20 ওহম. So by calculating it we will get potential difference 100 volt. Okay, now we have to find out the heat. So আমি already V value পালো, that is 100. Current already দিয়া হৈছে, it is 5 ampere and time it is given 30 second. Now do the multiplication, so we will get 15,000. Okay, so heat is 1.5 into 10 to the power 4 joule. Clear everyone? So questions were tough নহয়, but তোমালোকে formula বোৰ জানিব লাগিব আৰু কেনেকৈ apply কৰিব লাগিব হেতু জানিব লাগিব. For that purpose you need to practice a lot. Okay, so always try to do the calculation by yourself first. Now moving to question number 4. An electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and at 360 watt when the heating is at the minimum. The voltage is 220 volt. What is the current in each case? So guys, তোমালোকে কোৱেশ্চনটো যদি ভালকে পঢ়া তেতিয়া গম পাবা যে এই কোৱেশ্চনটো পাৱাৰৰ কোৱেশ্চন. কেনেকৈ গম পালো আমি? Because ইয়াৰ ইউনিটটো দিয়া হৈছে watt আৰু wattটো কিহৰ ইউনিট? Power unit, right? Okay, so এই দুটা কেস দিয়া হৈছে এটা maximum আৰু minimum. So power maximum দিয়া হৈছে 840 watt আৰু minimum to দিয়া হৈছে 640 watt. আৰু potential difference to কিমান dit হৈছে 220 volt. So we have to find the current in each case, that is the maximum current and minimum current. Okay, now see here, power at maximum P max equal to 840 watt and power at minimum it is given 360 watt and the potential difference is 220 volt. So we have to find out the current max and current minimum. Okay, now see here we will use the power formula, that is power equal to V into I. Now see the solution. So for the first case, when heating is at the maximum rate, that is when power is maximum, that is 840 watt. Here the potential difference, the voltage it is same, it is 220 volt for both maximum and minimum. So for now finding out the P max, we will use V into I max. Okay, now by rearranging it we will get P max upon V equal to, by putting the value 840 upon 220 and then calculating it we will get current maximum equal to 3.82 ampere. Okay, now look at the second case, when the heating is at the minimum rate, that is when power is minimum. So power to the minimum tar value to hoise 360 watt aru potential difference is 220 volt. So current minimum equal to 360 upon 220. Now by calculating it we will get current minimum equal to 1.64 ampere. Okay, so current max is 3.82 ampere and minimum current is 1.64 ampere. So it was a simple power question asil. Clear everyone? So tumalike a formula to janibo laibo, power equal to V into I. Now see question number 5. An electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volt, the power consumed will be. So এতিয়া ফাৰ্ষ্টতে potential difference 220 volt থাকোতে power 1 to হৈছে 100 watt. Now if it is operated on 110 volt, then power 2 will be. So we have to find out the power 2. Okay guys, now see here, we are given power 1 equal to 100 watt, potential difference V1 equal to 220 volt, V2 equal to 110 volt. So we have to find out power 2. So from here we can use the power formula P equal to V square upon R. Okay, now see the solution. So we know the value of P1 equal to V1, right? So by putting the value 100 equal to 220 square upon R, we can find the resistance. That is R equal to 220 square upon 100, we get R equal to 484 ohm. Okay, so it is our resistance to 110 ot constant thakibo. Okay, it will remain constant. Therefore P2 equal to V2 square upon 100. So now we can find the value of P2. So V2 equal to we know that it is 110 square and R equal to 484 since it is constant. So by calculating it, we will get power 2 equal to 25 watt. Okay, so the power consumed at 110 volt is 25 watt. I hope everybody understood. Okay, now moving to question number 6. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of the bulb? So here potential difference dia hoy ase 220 volt aru current to 0.5 ampere. So we have to find the power of the bulb. Okay guys, so pause the video and try to do it by yourself. Okay, now let me help you. So we are given current equal to 0.5 ampere, potential difference is 220 volt. So we have to find out the power. So we can use the power formula from the given values, power equal to V into I. So we know the value of V and I, right? So by putting the values and then calculating, we will get power equal to 110 watt. So the power of the bulb is 110 watt. Formula based question, right? Now moving to question number 7. An electric heater of resistance 8 ohm draws 15 ampere from the main service for 2 hours. Calculate the rate at which heat is developed in the heater. So guys, it question dot ki dia hoise swa resistance dia hoise aru current to dia hoise. So we have to find the heat. So heat mane hoise power. Now see here, we are given resistance is 8 ohm and current is 15 ampere. So we have to find the power. So from here we can use the power formula P equal to I square into R. Now see here, P equal to I square into R. So we know the value of I and R, that is 15 into 8, right? So 15 square into 8, by calculating it we will get power equal to 1800 joule per second. So the heat is produced by the heater at the rate of 1800 joule per second. Clear everyone? Alright, now see question number 8. Two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric main supply. Okay, now what current is drawn from the line if the supply voltage is 220 volt? Okay, now see here. So question to dia hoy ase duta lamp, that is these two lamp of power 1 and power 2 are connected in parallel, as you can see here. So power 1 is 100 watt and power 2 is 60 watt and the potential difference is 220 volt. Okay, so we have to find out the current. Ami current uliabo laibo. Okay, now see here, we are given power 1 is 100 watt and power 2 is 60 watt and the potential difference is it is same, that is 220 volt. So we have to find the current. So from here we can use the power formula P equal to V into I. Okay, now see here, current drawn by the bulb of rating 100 watt is P1 equal to V1. Okay, so we know that I1 equal to P1 by V. So P1 or value to dia hoise, that is 100 watt and the potential difference is 220 volt. So I1 equal to 100 upon 220 ampere. Keep it like this. Okay, now similarly, current drawn by the bulb of rating 60 watt is now P2 equal to V into I2. Therefore, I2 equal to P2 into V. So it ami P2 value janu, it is 60 watt and V is 220. Therefore, current 2 equal to 60 upon 220 ampere. Okay, now see here, current drawn from the line equal to I1 plus I2. So etia line dalot kiman current draw hoise hetu uliabole hole ami duita current, that is I1 aru I2 add koribo laibo. Okay, so after calculating it, the current drawn from the line equal to 0.727 ampere. I hope everybody understood. So guys, now let's discuss the small topic which is left to discuss, that is electric power. So tumaloke electric meter to logot familiar, right? So electric meter to eta unit thake, he unit to kilowatt hour thake. Okay, so the electric power burile ki buja? Definition to swa, electric power is the rate at which electric energy is dissipated or consumed in an electric circuit. So electric power to hoise eta rate, so the electric circuit electric energy to consume hoy. Okay, so power equal to work done upon time. So আমি জানো যে rate of doing work is called power. So this is also the rate of consumption of energy. So electric power equal to energy consumed upon time. So energy consumed formula to hobo power into time. Okay, now see here unit of electric energy. So electric energy unit to key. It is power unit to hoise watt or timer unit to hoise second. We will consider it in second. Okay, so watt into second. Now see here energy consumed in bigger units equal to kilowatt into hour. So actually a unit watt to etu bahut horu, therefore ama juntu actual practice ba ami practically juntu daily life ot use koru, we use a much bigger units and it is kilowatt hour. Okay, so a kilowatt hour to hoise 1 unit. Now see here relation between commercial and SI unit of work. 1 kilowatt hour equal to 1000 watt into 3600 second. So etia 1 kilowatt ot 1000 watt thake. Okay, so etia hour to seconds ole convert korile we will get 3600 seconds because 1 ghonta 3600 seconds thake. So we can write 1 kilowatt hour equal to 36 into 10 to the power 5 watt second. So kilowatt hour equal to 36 into 10 to the power 5 joule. So 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule. So electric energy commercial unit to hoise kilowatt hour, which is written as kWh. Okay, aru commonly unit buli koy. Okay, so ite bohote hoyto bhabe je electric circuit etat electrons consume hoy, but this is not true. This is wrong. আমি ইলেক্ট্ৰিচিটি বোৰ্ডক পে কৰো এনাৰ্জি প্ৰভাইড কৰিবৰ কাৰণে, আৰু এনাৰ্জিটো কেনেকৈ প্ৰভাইড হয় যেতিয়া আমাৰ ইলেক্ট্ৰনিক গেজেটছ বিলাকত লাইক ইলেক্ট্ৰিক বাল্ব, ফেন, টিভি এক্সেট্ৰা ইঞ্জিনছ এইবিলাকত যেতিয়া ইলেক্ট্ৰনছ মুভ হয় তেতিয়া এনাৰ্জি প্ৰডিউচ হয়. So basically we pay for the energy that we use. Okay guys, now let's do some numericals of type E. So here we will use the formula electric power equal to energy consumed upon time in hours. Okay, now see here electric power should be in kilowatts and the time should be in hours. Okay, so power to kilowatts ot hobo lagibo aru time to hours ot hobo lagibo. Am I clear? Okay, now see question number 1. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of the energy to operate it for 30 days at rupees 3 per kilowatt hour? So itia question to ki dia hoise swa, power to dia hoise, time to dia hoise aru cost to dia ase. So we have to find out the energy consumed. So kiman energy consumed hoise ami hetu ulebo lagibo. Now see here we are given power equal to 400 watt. So already moi initially koisu je watt thakile eto ami kilowatt le convert koribo lagibo. Am I clear? So itia ami 400 watt to kilowatt le convert koribo lagibo. So convert koribole hole we have to divide this 400 by 1000. Okay, and we will get 0.4 kilowatt. Now see here time to dia hoy ase kiman 30 days and 8 hours per day. So ite ami 30 aru 8 to multiply koribo lagibo. So we will get 240 hour and the cost is given, that is cost per kilowatt hour, it is rupees 3. Okay, so we have to find the energy consumed. So from here we can use the formula, that is energy consumed equal to P into T, right? So by putting the value of P into T we will get energy consumed equal to 0.4 kilowatt into 240 hour. So energy consumed is 96 and the unit is kilowatt hour. Am I clear everyone? Okay, now see here the cost of energy equal to 96 into 3. Since cost is 3 per kilowatt hour, so 96 kilowatt hour hobole hole ami multiply koribo lagibo. So we will get cost of energy equal to rupees 288. So the answer is the cost of energy to operate a refrigerator for 30 days is rupees 288. I hope everybody understood. Now see question number 2. An electric heater rated 1000 watt upon 220 volt operates 2 hours daily. Calculate the cost of energy to operate for 30 days at rupees 3 per kilowatt hour. So question to ki dia hoy ase swa, power to dia hoy ase aru time to dise. Okay, so we have to find out 30 days at energy cost to kiman hobo. Okay, so we are given power P equal to 1000 watt. So এতিয়া unit to watt to ami kilowatt le convert koribo laibo, right? So ami janu je 1000 watt equal to 1 kilowatt, and time it is given 2 hour per day, that means 2 hours daily. So we have to find the cost of energy to operate for 30 days. Okay, so we can use the formula energy consumed equal to P into T. So see here, energy consumed by electric heater equal to, now we know that power equal to 1 kilowatt and the time is 2 hour. So we will get 2 kilowatt hour. Now see, the cost of energy to operate equal to 2 into 3. So cost to dia hoy ase rupees 3 per kilowatt hour. So 2 kilowatt hour hobo 2 into 3, that is rupees 6 per day. Now see the cost of energy to operate for 30 days. So etia ami edinor he palu cost to, that is rupees 6 per day. So 30 days of energy cost to hobo 6 into 30, it is rupees 180. So the cost of energy to operate electric heater for 30 days is rupees 180. Okay, now moving to question number 3. A 100 watt electric bulb is lighted for 2 hours daily and 440 watt bulbs are lighted for 4 hours every day. Calculate the energy consumed. So etia question to ki dia hoy ase swa, power 1 it is given 100 watt. So to watt dia hoy ase, we have to convert it into kilowatt. So we have to divide by 1000 and we will get 0.1 kilowatt. Time to dia hoy ase, time 1 equal to 2 hours and power 2 is 40 watt and time 2. So again we have to convert this watt into kilowatt. So we will get 0.04 kilowatt and time 2 it is given 4 hours. Okay, so etia ami ei duta kesot energy kiman consume hol hetu uliabo laibo. Clear everyone? So we have to find out the energy consumed in each case. Now see the formula here, energy consumed equal to power into time. We know that, right? So in the first case we will find for power 1 and time 1, that is P1 into time 1. So we will get 0.1 into 2, that is energy consumed equal to 0.2 kilowatt hour. So energy consumed by 100 watt bulb in 1 day is 0.2 kilowatt hour. It is a second case of energy consumed equal to P2 into T2. So ami janu je, so it is second case of 440 watt bulbs dia hoy ase. Okay, 4ta 40 watt bulbs. So we have to multiply by 4. So we will get 4 into 0.04 kilowatt into 4. So we will get 0.64 kilowatt hour. Energy consumed by 440 watt bulbs in 1 day is 0.64 kilowatt hour. Therefore total energy consumed equal to, so etia ami duita kesore total energy to uliabo laibo. Okay, so total energy equal to, we have to add both this 0.2 plus 0.64. After calculating it, we will get 0.84 kilowatt hour. So the total energy consumed is 0.84 kilowatt hour. Now see question number 4. Which uses more energy? A 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes. So question 2, power 1 dia hoy ase 250 watt aru power 2 dia hoy ase 1200 watt. And time is also given, that is T1 and T2. So kontue besi energy use kore ami hetu uliabo laibo. Okay, now see here, we are given power 1 equal to 250 watt. So eta ami watt to kilowatt le convert koribo laibo. Don't forget that. So we will get 0.25 kilowatt and power 2 equal to 1200 watt, which is equal to 1.2 kilowatt, and time T1 equal to 1 hour and time 2 equal to T2, that is 10 minutes. So etia to minutes dia hoy ase, we have to convert it into hour. Okay, so we will get 10 by 60 hour, that is 0.167 hour. Okay, now we have to find the energy consumed. Now see here, the formula from here we can use energy consumed equal to P into T, right? Okay, now see here, for the first case, that is in case of TV set, energy consumed by TV P1 into T1. So আমি জানো যে P1 এর ভ্যালু টু দিয়া হৈ আছে 0.25 kilowatt and T1 is 1 hour. So energy consumed equal to 0.25 kilowatt hour. Now see here, in the second case, that is in case of toaster, energy consumed by equal to P2 into T2. So we know that P2 equal to 1.2 kilowatt hour into 0.167 hour. So after calculating it, we will get 0.2 kilowatt hour. So the energy consumed by 250 watt TV set in 1 hour is more than the energy consumed by 1200 watt toaster in 10 minutes. So এতিয়া TV set to energy বেছি consume কৰিব toaster tutke. Clear everyone? Okay, now see question number 5. A household uses the following electric appliances. Refrigerator of rating 400 watt for 10 hours each day. 2 electric fans of rating 80 watt for 12 hours each day. 6 electric tubes of rating 8 watt is for 6 hours each day. Okay, now calculate the electricity bill of the household for the month of June. If the cost per unit of electric energy is rupees 5 per kilowatt hour. So itia question tut ki dia hoy ase swa tinta case tinta power dia hoy ase aru time tinta dia hoise. So ami uliabo lagibo June mahot household electricity bill kiman hol. Okay, and it is also given cost per unit of electric energy is rupees 5 per kilowatt hour. Okay, so see here, power 1 equal to 400 watt. So convert it into kilowatt, we will get 0.4 kilowatt. And time 1 equal to, it is given 10 hours. Okay, 10 hour per day. Now P2 equal to 80 watt. So after converting it, we will get 0.08 kilowatt. And the time 2 is 12 hours each day. Okay, and the power 3 is given 18 watt. So convert it into kilowatt, we will get 0.018 kilowatt. And time 3 equal to 6 hour per day. And also cost per unit of electric energy is given rupees 5. So we have to find electricity bill of household. Okay, now see here, the formula here we will use energy consumed equal to P into T. Okay, so simple formula, but yet tinta case ase. Now see the solution. So first case to hoise refrigerator, that is energy consumed by refrigerator equal to P1 into T1. So আমি জানো যে P1 it is 0.4 and T1 hoise 10. So we will get energy consumed by refrigerator is 4 kilowatt hour. Now see the second case, energy consumed by 2 electric fans. So যেহেতু কোৱেশ্যনত দিয়া হৈ আছে দুখন electric fans, so আমি 2 এ multiply কৰিব লাগিব. Clear everyone? Don't forget that. Okay, so 2 into 0.08 into 12, we will get 1.92 kilowatt hour. Now see energy consumed by 6 electric tubes. So here tata dia hoy ase 6ta electric tubes. So we have to multiply with 6. So 6 into 0.018 into 6, we will get 0.648 kilowatt hour. So itia prothomote ami total electrical energy kiman consume hol hetu uliabo laibo. So hetu uliabole hole ami gote gita add koribo laibo. Okay, so after adding we will get 6.568 kilowatt hour. This is the total electrical energy consumed. Okay, now see here, the total electrical energy consumed in month of June. So it আমি জানো যে জুনত কিমান দিন থাকে 30 দিন 30 days, right? So এটা আমি 30 লগত multiply কৰিব লাগিব. So total energy consumed equal to 6.568 kilowatt hour into 30. After calculating it, we will get 197.04 kilowatt hour. Okay, so it electricity bill operation to hobo, we have to multiply it by 5 because we know that cost per unit of electric energy is rupees 5. So 197.04 into 5, we will get, it is rupees 985.2. Okay, So the electricity bill of household for month of June is rupees 985.2. Okay students, now let's do some more numericals. So see question number 1. Several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere? So guys, etia question tut ki dia hoy ase soa potential difference dia hoy ase aru eta bulbor electric power that is 10 watt and the maximum current is given, it is 5 ampere. So we have to find out the number of lamps to be connected in parallel. Okay, now see here, we are given potential differences 220 volt, maximum current is 5 ampere and the power of one bulb is 10 watt. So we have to find out the number of bulbs to be connected in parallel. So let X be the number of bulbs to be connected. Okay, so we will be using the formula power equal to V square upon R, V equal to IR, that is the Ohm's law. Now see here, since the bulbs are to be connected in parallel, so we will use the formula efficiency of resistance in parallel. 1 by R equal to 1 by R1 into X. So this X is the number of bulbs. Okay. Now see the solution here. So let R1 be the resistance of the bulb. So bulb to resistance was say R1. Okay. So from this formula we can easily find the value of R1. So etia ami V aru P1 or value jano, right? That is 220 and 10 watt respectively. So R1 equal to 220 whole square upon 10 equal to 4840 ohm and mark it as equation 1. Okay. Now see here, according to Ohm's law, we know that V equal to IR. So this R, it is the total resistance of the circuit. Okay. For X number of electric bulbs. So circuit to jiman number of bulbs ase, hetar total resistance to hoise R. So R equal to V upon I. Now we know that V is 220 and current it is 5 ampere. So resistance equal to 44 ohm and mark it as equation 2. Now see here, since the bulbs are to be connected in parallel, so we will use this formula 1 by R equal to 1 by R1 into X. Now see from equation 1 and 2, it equation 1 aru 2 pra ami R1 aru R values kita janu, right? That is X equal to R1 upon R. So R1 er value to hoise 4840 from equation 1 and R value to hoise 44 from equation 2. So we will get X equal to 110. So 110 electric bulbs are connected in parallel. I hope there is no doubt. Now moving to question number 2. A copper wire has a diameter of 0.5 mm and resistivity of 1.6 into 10 to the power minus 8 ohm meter. So question A says, what will be the length of this wire to make its resistance 10 ohm? And question B says, how much does the resistance change if the diameter is doubled? Okay, so ita question tut ki dia hoy ase so edal copper wire resistivity dia hoy ase 1.6 into 10 to the power minus 8. Diameter to hoise 0.5 mm. So question 8 koise jodi resistance to 10 ohm hoy tetia length to kiman hobo. So we have to find out the length. And question B says jodi diameter to double hoy tetia resistance to kiman change hobo. Alright, now see here. So we are given resistivity is 1.6 into 10 to the power minus 8 ohm meter. Resistance is 10 ohm and diameter is 0.5 mm. So it unit to swa millimeter dia hoy ase. So first ami diameter to radius ot ulialom aru tar pisot millimeter to ami meter le convert korim. Clear? So radius equal to 0.25 into 10 to the power minus 3 meter. So tumalike unit to change koribole napahoriba. Okay? Now we have to find the length and resistance. How much does the resistance change if the diameter is double? So diameter to double hole resistance kiman change hobo hetu uliabo laibo. Now see here, we will use the formula R equal to rho into L by A. So it ami janu je area equal to pi r square, right? Okay guys, now see the solution here. So we can write the formula as resistivity rho equal to R into A by L. Now by putting the value of resistance, that is 10 ohm, ami ta area to pi r square likhibo paro, right? So we know the value of pi, that is 3.14 into radius is how much? Yes, it is 0.25 into 10 to the power minus 3 and it is whole square. And resistivity is 1.6 into 10 to the power minus 8. So it seems to be a bit calculative, but let's do the calculation. So eneko down calculation bilak tumalike jiman nije try koriba himan gom paba keneke approach koribo lage. Clear? So after calculating it, we got length equal to 122.65 meter. So this is the length, okay? Now see for B, we have to find out the resistance change if the diameter is doubled. So ami janu je resistance is inversely proportional to diameter. So when the diameter of the wire is doubled, then its resistance will become half, that is half whole square or 1/4. So wire diameter to jodi double hoy tetia resistance to half hoy jabo, because it is inversely proportional. I hope everybody understood. Now moving to question number 3, compare the power used in the 2 ohm resistor in each of the following circuits. A 6 volt battery in series with 1 ohm and 2 ohm resistors, and a 4 volt battery in parallel with 12 ohm and 2 ohm resistors. So guys, etia question to chua duta circuit ase, eta series aru eta parallel, okay? Aru 2 ohm to duitate common. Now see here, we have to compare the power. Okay, so see here, this is the first circuit. So resistance R1 equal to 2 ohm and resistance 2 equal to 1 ohm. So both are connected in series, okay? They are connected end to end. And potential difference is 6 volt. So we have to find out the power one. Now see the other circuit which is connected in parallel. So R3 and R1, they are connected in parallel, as you can see here. And the potential difference is 4 volt here. So we have to compare these two power, okay? So now see here, current in both the circuit is I. So duita circuit ote current to hoise I. Resistance is 2 ohm, hence by using the formula P equal to I square into R, power used in both cases will be the same. So itia duita circuit ote current to hoise I aru resistance 2 ohm. Therefore we can use the formula this P equal to I square into R, okay? Aru itia duita case ote power to same thakibo. So now see here, we are given resistance equal to R1 equal to 2 ohm, resistance R2 equal to 1 ohm, resistance 3 equal to 12 ohm, and potential difference V1 is 6 ohm and V2 is 4 ohm. So what we have to find? We have to find power 1 and power 2. Now see the formula we will be using. Effective resistance in series, RS equal to R1 plus R2. Since the first circuit is connected in series, so we can find the value of RS. Second formula is V1 equal to I into RS, that is Ohm's law, right? Third one is P1 equal to I square into R1, and fourth one is P2 equal to V2 square upon R1. Okay, now see the solution here. For case 1, resistor 1 ohm and 2 ohm, they are connected in series. So we can use this formula, right? So ite ami 1 ohm aru 2 ohm resistors add korile ami RS to pai jam, that is 3 ohm. Now by using Ohm's law, V1 equal to I into RS, so ইয়াৰ পৰা আমি current to পাম, right? So আমি জানো যে V1 or value to হৈছে 6 volt আৰু RS to হৈছে 3 ohm. So from here we got current equal to 2 ampere. Now from this formula we can find out the value of P1. So we know that current is 2 ampere and R1 is 2 ohm. Therefore power 1 is 8 watt. Okay, now see here case 2, where resistors 12 ohm and 2 ohm are connected in parallel. So ita case 2, 12 ohm aru 2 ohm resistor to parallel connection at ase, right? Iti ami jano je parallel connection or potential difference to same thake. Therefore potential difference across 2 ohm resistor will be 2 volt. So jihetu parallel combination or potential difference same thake, he karne 12 ohm resistor to potential difference 2 volt thakibo. I hope everybody understood this point. Therefore, by using this formula, we can find the value of P2. Now we know that V2 is how much? It is 4 volt. So for 4 square upon R1 is, we know it is 2 ohm. Upon 2, we will get power to equal to 8 watt. Hence, we can conclude that the power used by 2 ohm resistor in both the cases is 8 watt. So guys, it was an interesting question asil because here tumalike dekhisa every concept use hoise, right? from effective resistance in series to power. So প্ৰত্যেকটো কনসেপ্ট কেনেকৈ এটা কোৱেশ্চনত এপ্লাই হয় হেতু তোমালোকে জানিব লাগিব আৰু হেতু একচুয়ালি তোমালোকে কোৱেশ্চনছবোৰ যিমান প্ৰেক্টিস কৰিবা হিমান ইজিলি গম পাবা কোড কেনেকৈ এপ্লিকেশনটো হয় Okay guys, I hope there is no doubt. Now proceed to question number 4. Calculate the effective resistance between P and Q. So it is P and Q effective resistance to liya bolaibo. Okay, now see here. Resistance PAQ. So it is ami PAQ resistance to total resistance to liya paro, right? As we can see here, they are connected in series. Therefore, we can use the formula effective resistance in series. So 7 plus 3 equal to 10 ohm. So this is 10 ohm. Now see here for resistance PBQ, again they are connected in series, therefore 6 plus 4 equal to 10 ohm. Now 10 ohm, 1 ohm and 10 ohm resistances are in parallel between P and Q. So here resistances 10 ohm, 1 ohm or 8 to 10 ohm, they are in parallel between P and Q. So we can use the effective resistance in parallel formula, that is 1 upon R equal to, now we can put the value of R1, R2 and R3, that is 1 by 10 plus 1 by 1 plus 1 by 10. Now by calculating it, we will get R equal to 5 by 6 ohm. So 5 by 6 ohm to is effective resistance between P and Q. Am I clear guys? Okay, now see the last question. 5 resistors are connected as shown in the figure. So see here, 5 resistor connect kora hoy ase. Now we have to find the ammeter reading when the circuit is closed. So first today ami B aru D er majot total resistance kiman hetu liam. Okay, now see here, between B and D 3 plus 3, as you can see here, B aru D er majot duta series connection ase, that is 3 ohm plus 3 ohm. So total resistance in series equal to 6 ohm. So next ami effective resistance in parallel formula to use korile total resistance to pi jam between B and D. Okay, so 1 by Rp equal to 1 by Rs plus 1 by 3, this 3 equal to 1 by 6 plus 1 by 3, which is equal to 3 by 6, that is 1 half. Okay, so Rp equal to 2 ohm. So it ami 3 ohm plus 3 ohm e duta ami palu, that is 6 ohm. So a2 tetia effective resistance in parallelot ami add koribo laibo. Okay, and this is the third resistance 1 by 3. So adding all these things, we got Rp equal to 2 ohm. Now see the other case between A and E. Ete A aru E er majot total resistance kiman. So similarly, by adding these two, 0.5 plus 0.5 and the total resistance Rp equal to 2 ohm, we have to add this one also. So effective resistance between A and E in series equal to 3 ohm. Okay, so therefore I equal to V by R. So it ami V to janu, that is 3 volt potential difference, our total resistance ami kiman palu 3 ohm. Keneke 3 ohm palu? I hope everybody understood. Okay, akorbar mo koi disu. Prothomote ami B aru D majot uliyai lolu total resistance kiman hoise, that is first sote ami ei duta add korilu because they are in series. So add korar pisot ami parallel connection formula to use kori pela a2 connect korilu, adding these two. Okay, so ami palu 2 ohm. Okay, next ami effective resistance between A aru E majot jiman effective resistance ase hetu ulialu, logote ami B aru D majot jiman asile resistance hetu add korilu. Thus we got a total resistance R, which is equal to 3. So therefore ammeter reading equal to 1 ampere. So current is 1 ampere when the circuit is closed. So students, we have completed one of the challenging chapter, that is electricity. So etu chapter 5ta effective lecture ase aru tumalukor karne class kita jodi he helpful hoise tene hole friends er logot share koribole napahoriba. Aru chapter 2 notes amar official WhatsApp group tut pai jaba. Okay, so group tut jodi join hua nai, join hobole hole amar description box ot eta WhatsApp number dia hoy ase, he number to text eta kori dile group tut join korai dibo. Clear? Aru kiba doubt thakile freely comment ot hudibo para. Thank you.